whatever comes after this.
Yes, sir.
So, start with 1. I noticed that you've already done a lot of work here. Is this your work, or is that the teacher's work, or?
That was some notes on it. It's my work.
Okay. All right. I'll just kind of ignore it, and we'll just solve it together here.
Yes, sir.
Hold on. So, number 1.
Yes, sir.
Log base 10 of 4 divided by log base 10 of 1/4. Let's
Yes, sir.
do this by adding a variable. So I'm going to say the log of 4 is equal to x.
All right.
And the log of 1/4 is equal to y. In the top equation, convert that to exponential. What does that say?
So that is that would be
the way I do
10 to
it,
the.
I always start with the base,
Yes,
raise
sir.
it to the power of what's ever on the right side, and that's equal to the argument. It's just a quick and dirty way
Yes,
of always converting it. As long as your log expression is on the left, that works. And this one
yes, sir.
is 10 to the
10 to the x equals 4 and 10 to the y equals 1/4.
So when so the numerator becomes 10. Hold on a moment. Never met a log problem I couldn't do. Why is this giving me problems? The key to this problem is the fact that there is a common exponential base between 4 and 1/4.
Yes, sir.
4 is the same as 4 to the negative 1.
Yes, sir.
Perhaps that's the way we need to do it. In other words, I can write this as the log of 4 divided by the log of 4 to the negative 1.
Oh, okay.
And 4 to the negative 1 is 1/16, or excuse me, it's 1/4. Now, usually, I'm going to go out on a wild spring here and say the answer is 16. Question is why? Because this can be represented as 10 to the x, and the bottom can be represented as 10 to the x plus 1. No. This undoubtedly is not a calculator problem, right?
Yes, sir.
And in fact, the more I think about it, the answer shouldn't be 16. It would be too easy.
Since it's the same base,
Okay.
and since the top is basically the log of 4 to the first, and then the bottom is 4 to the negative first.
Right.
Do those powers have anything to do with it? Because I've checked the answer.
Okay. What is the answer? That'll help us.
Okay. Well, they want us to do it just working it out regularly, but I checked the answer for this on a calculator. The answer is -1. So I was wondering if it's those exponents that have anything to do with it.
Well, oddly enough, that was kind of what I put down. In other words, remember when I put down that's equal to x, and this was equal hold on, let me think about this for a moment.
Yes, sir.
So what if we did this? What if we say that's equal to x? We don't know what it's equal to, so we're going to say it's equal to x.
Yes, sir. Okay.
And now I'm going to multiply both sides by the denominator. So it's the log of 4 equals x times the log of 4 to the minus 1. And now we can take that exponent and put it down in front. So we have the log of 4 equals minus x, the log of 4.
Oh.
And then that we can divide both sides by the log of 4, and we get the whole thing is equal to minus x. Now, how does that necessarily translate to -1?
Oh, well, that's 1 is equal to -x? Or?
Well, x is 1, apparently. If your answer says -1, then x has to be 1, because we have -x. Oh, yeah, no, you're absolutely right. There we go. I forgot to replace it with a 1. So we have 1 equals -x, x equals -1. There you go. That's the way to do it. Man, these are hard. Here I thought I was going to give my brain a break. All right, let's look at number 2 here.
Okay. So log of 2 equals A, log of 7 equals B.
Well, first of all, when you see something like that, you know you're probably going to have to separate it. So what's the log of 98 divided by the log of 9? In terms of these numbers right here.
Oh, okay.
So if you're going to have to factor 98. You can divide by the log of 9, but this thing becomes the log of something plus the log of something else minus the log of 9.
Oh, that's right. Isn't adding logs the same as multiplying?
Yes. In other words, whenever the argument has multiplication in it, you can add the two. When it has division in it, you subtract it.
Okay.
So
So that would be,
go ahead.
wait, what were you going to say?
Well, 98. Let's figure out how we can factor 98. Because that's the first step. Okay? So that could be 49 times 2. Well, notice that's one of those times one of those. So it's 7 times, let's start again. I'm going to start more to the left. So the numerator is the log of 98 minus the log of 9. Okay?
Yes, sir.
And now 98 is the log of 7 plus the log of 7. That's 7 times 7 plus the log of
2.
Still subtracting the log of 9. And I think we can leave that as a log of 9 because they've got that there.
Okay.
Now let's go back and substitute the A, B, and C.
So that would be 2b plus a.
Hold on. Yeah. Let's see. The log of 7 is B. Yeah. So 2b plus a minus c. That should be your answer.
Yes. Yes, sir.
It'll be a plus 2b minus c.
That's right. That's right. A plus 2b.
Okay. Number 3. Find the log base z of w if that's equal to that, that's equal to that, and that's all equal to that. Okay.
All right.
And that is find the log base z of w.
Log base z of w.
Not missing any stuff there?
No, sir.
All right, so what are we going to do here? Let me think for a second. So we take that expression and say x to the 36th power equals w. And
Okay.
say y to the 18th power equals w.
Okay.
And I can say x, y, z to the 12th power equals
W squared.
Yeah. Okay.
And x, y, z to the 12th, that is x times y times z quantity to the 12th?
Yes. Sorry.
Okay.
I forgot those. Thank you.
Okay, I want to.
Actually, that's helpful because that means w is equal to x, y, z to the 6th.
Oh. Okay, that's right.
The square root of both sides. Now we got w equal to 3 things. So we now have 4 variables and 3 equations.
Yes, sir.
You may want to know what the log base z of w is.
So could we, what were you planning on doing?
I don't know.
I
I'm
was,
sitting here pondering it. If you have suggestions, by all means, jump in.
is there any way that we could do it by setting any of this equal to each other, like x to the 6th, y to the 6th, z to the 6th is equal to y to the 18th? Or is there any way to do it from that?
No, I think you're on the right track. Let's play with that. X to the 6th, y to the 6th, z to the 6th is equal to y to the 18th. We can immediately divide out the y to the 6th, so that's equal to y to the 12th. And it's also equal to x to the 36th. Let's go up here and write x to the 6th, y to the 6th, z to the 6th. We can divide that out, making x to the 30th equal to that. And now, let's see, if we take the 6th root of both sides from here, we get xz equals y squared.
Okay.
And if we take the 6th root of that, we get x to the 25th equals yz. We have to do the same thing for that one also.
So now do we have something that's equal to z?
Well, I don't know. We're getting close. Let's see. We have xz equal to y squared from this one down here. We have x to the 25th equals yz from that one up there. And this one is going to be equal to x 6th, y 6th, z to the 6th. Take out the y's, that becomes a 12. So here we have xz equal to, hey, what happened? Okay,
I got
xz equals y to the 12th. Well, that's peculiar right there. We got y to the 12th equals y. We've either made a mistake or y can only be 1. And if y is 1, z is x to the 25th. What do they want? They want the log base z of w, which means z to something equals w. I have an equation that, here's w.
well, I was just thinking
w.
I was thinking when you had gotten the x, what, sir?
I think that we will be able to solve for z to some power equals, I don't know, I'm getting lost. We're on the right track. We just have to keep track of our logic.
Yes, sir.
and I've made a mistake somewhere because I don't like this y equals xz, and y to the 12th equals xz. Where did I get that? We got x.
When you had gotten the xz equals y squared and yz equals x to the 25th, I set those equal to z, so I got z equals y squared over x and z equals x to the 25th over y, and then I set those two equal. I don't know if this went any farther.
Okay, so what'd you get? Y squared over x equals what?
All right. Y squared over x is equal to z.
Okay. What's the other z equal to?
X to the 25th over y.
Okay. Takes away that y, and that's squared. Takes away that x. So now makes that a 24. So now we have a y equals x to the 24th.
Okay.
What we need is w. We got y to the 18th equals w from this middle equation right there. Because what they're looking for is z to some power, question mark, equals w.
So
y to the 18th equals z to that question mark.
So could we just plug in y to the 18th for the w on the log base xyz, w squared equals 12? And since we have...
So you have y to the 18th. Okay, I went through this process once. Right, like that? Oh no, that's equal to w squared. So y to the 18th is equal to w, but this is xyz to the 12th equals w squared. So that's not y, that's w squared.
Yes, sir.
So w equals x to the 6th, y to the 6th, z to the 6th.
Yes, sir.
I don't know. Why don't we table this one? Let me think about it. Maybe one of us will have a enlightenment on it.
All right.
Sometimes you just have to take these problems and stare at them for a while and think about them for a while.
That's right.
And before the solution comes to you. I'm pretty sure I can get it if given enough time to think about it, but doing it on the fly is tough.
Yes, sir.
So I would say let's not waste any more time on this for the moment.
Yes, sir.
Let's look at number 4.
Number 4.
So we have the log base 4 of something minus the log base 4 of something else is equal to 0.5. So first of all, let's combine those into a single log expression.
Yes, sir.
What would that be?
So this would be log base 4 of absolute value of 2x plus 2 times,
No.
or divided by. divided by the absolute value of 3x plus 1 is equal to
Okay, first,
point.
yeah, go ahead. That's true. We need to decide what to do with these absolute value signs. So we actually
Okay.
this over that.
Okay.
Now, the question is that the same as the absolute value of the whole fraction? And I believe it is. I believe the absolute value of A divided by absolute value of B is the same as the absolute value of A divided by B. If you think about it, it has to be. Because
Yes, sir.
if one's negative, if the numerator were negative, it would turn positive. Same with the denominator. So that fraction, if that were negative, we'd want to make it positive. So I can definitely add that, I think. With logs, you got to be really careful, and we're going to have to make sure we check.
Yes, sir.
What's the next step?
Okay, so that is 4 to the 1/2 power is equal to the absolute value of 2x plus 2 divided by 3x plus 1.
Okay. We know what that is. That's 2.
All right.
Now,
1/2 the square root.
yeah, and now at this point, let's see what happens if we just go ahead and solve it normally and ignore the absolute value for a moment. I'm not sure we can do that. I think we're going to have to set that equal to 2, and we're also going to have to set it equal to minus 2. And
yes, sir.
We're going to come up with 2 different solutions for x, and then I believe we're going to find that, no, both of them might be correct, now that I think about it. So let's do that. Here, make some room. Sorry about my dog. When it thunders out, my dog barks, and there's just nothing I can do about it. So I'm going to say that let's solve this equation first. So 6x plus 2 equals 2x plus 2, which makes 4x equals 0, x equals 0.
Okay. Yes, sir.
Now I'm going to say the whole thing's equal to minus 2, which means minus 6x minus 2 equals 2x plus 2, which means minus
So x is negative.
Yeah, minus 4x equals 4, x equal negative 1.
1/2.
So
I got x is negative 1/2.
Gotta move the 2 to the other side, so it becomes minus 8. You were right. Negative 1/2. Thank you. Okay, now let's see what happens when we plug those in. Well, clearly, regardless of what the argument is, we're going to take the absolute value of it.
That's right.
So
Okay.
we're going to have the log of, let's just plug in both of them. We're going to have the log of 2, plugging in x equals 0, minus the
So log base 4 of 2.
of 1 equals 0.5. Well, the log of 1 is always 0.
That works.
So is 4 to the 1/2 power equal to +2? Yes, that solution seems to work. The 0 solution.
Yes, sir.
Now let's try the -1/2 solution. Don't need this anymore. So we have log base 4 of -1/2 makes that the log of 1.
Okay, so that would be 0. And then minus the log of 1.
-1/2 makes the argument -1/2, the absolute, so it's -1/2. We're fine. Hold it, are we? 0.5. This is 0, but this is
Is it
well,
-1/2?
remove the absolute value markers. That becomes 1/2. So the question is, is the square root of 4 equal to 1/2? No, it isn't. That's not a solution.
So there's only one solution.
That's the only one I can see. You have the answer on this one?
No, sir.
Do you have the answer on just the odds?
No, sir. Hold on, let me see.
Actually, because of that absolute value sign, I would have expected it also to work. But when I plug in -1/2, I get -3/2 plus 1, which is -1/2, and that is no longer equal to 2.
Really? Okay.
Yeah, it's another thing. I thought I had all the log problems, but I never had to deal with the absolute values very much. And I think that's what's giving me problems. I want to back up a second to this statement I made where the absolute value of that ratio is equal to +2 or -2.
Okay.
In other words, this thing right here has to equal plus or minus 2. Because when I take the absolute value of it, I get 2. So therefore, I can say that that ratio is equal to 2 or it's equal to -2.
That's right.
And when I made it equal to 2, x came out to be 0, which is a satisfactory solution. And when I made it equal to -2, let's just redo that math. -6x minus 2 equals 2x plus 2, means -8x equals 4, x equals -1/2. And when you plug x equal that comes out to be log of 1. This comes out to be log of -1/2. And even if you apply the rules of logs, you get the log of 1 divided by minus 1/2 equals that. And that's not true. Right? We didn't make a mistake in our math, did we? In other words, I'm pretty sure about this absolute value thing now. We have to set equal to 2, and we have to set equal to minus 2. But it doesn't necessarily have to satisfy both. In other words, it's kind of like having extraneous solutions. Let's just double check our math here. If x equals minus 1/2. So I've got the log base 4 of 1, right?
That's right.
Minus the log base 4 of minus 1/2. So that becomes log base 4 of 1 minus the log base 4 of 1/2. Is all of that equal to 0.5? Well, we know that's equal to 0.
Oh.
What? Go ahead.
I think. Okay, so log base 4 of 1, that's right, that's 0, minus log base 4 of 1/2 equals 0.5. So
now if I move that 1/2 to the there, I don't even have to do that.
So
yes. Oh, yes, I do have to do that. Hold on, that's a key step. We're down to this over here on the left, correct?
Yes, sir.
The question is that a true statement? Well, I'm allowed to take that coefficient and move it to there. Now it is a true statement.
Okay.
Because that is the same as 2. So this whole thing becomes log base 4 of 2. Is that equal to 0.5? Yes, it is. 4 to the 1/2 power is equal to 2. So that answer works also. There are 2 answers. X equals 0. That shows you the importance of taking that negative sign in front of a log and applying it immediately as an exponent to the argument.
Yes, sir.
Because otherwise, this doesn't look like it's a proper equation.
Yes, sir.
All right.
Why is it that with logs you're able to take an exponent and put it that's on the argument and put it in front of the log?
That's just a property of logs. In other words, the log of a to the b power, one of the identities, is that. You can always do it, no matter what b is. Even if b is x to the 9th, or even if b is the square root of x squared plus 1. In other words, no matter how complicated b is, you can always do that. And vice versa.
Okay.
You can always start from the right and go to the left, which is what we had to do with that problem.
Yes, sir.
Okay. So yeah, I suspect the mistake that will be made on that problem is people won't find the second solution. They'll find the x equals 0, but they'll miss the second solution because they don't interpret the absolute value properly. You gotta set it equal to 2 or minus 2. All right.
That's right.
Let's
yes, sir.
Number 5. So,
number 5.
Yeah. How do we solve exponential equations? Always. In other words, there is no way to algebraically solve it. You have to invoke what?
Logarithms.
Okay. What are we going to do to both sides?
So we have the log of...
Use the natural
wait, we're going to take the log of both sides.
Yeah, and I'm going to have you use the natural log.
Okay.
Just because it's the best one to use. In other words, some people would maybe use the log base 5 or the log base 3 of both sides. Doesn't really save you any steps, and it's just always take the natural log. Okay? You can't go wrong by always taking the natural log of both sides. And natural log is the log of calculus. Once you get to calculus, log base, anything else kind of goes away. Everything is natural log. Okay? So now what can we do using that same rule we just talked about?
We can... what is it? We
take that exponent and take it down and make it in front of the coefficient.
That's right.
On both sides. So here's what we end up with. Now, this can be a little confusing because we're not used to having the variable in front of the coefficient. But that's what we have here. Natural log of 5 is a number. Okay, so I could put it in front of the 2x plus 2. But it doesn't come out that way. When you use rules of logs, it comes out this way. And then you can turn it around if you want. Okay, now this is still a little bit tricky. Not terribly, but at least I know how to do this one. We have to distribute. That natural log of 5 is a number, so is the natural log of 3. So let's distribute.
Yes, sir.
What do I get when I distribute that?
So you get 2x natural log of 5 plus 2 natural log.
Yeah, this time I'm going to put it in front times 2x.
Okay.
Plus natural log of 5 times 2. I'm going to put the 2 in front there. Because now I can move it back to an exponent, and that becomes the natural log of 25. But let's not do that yet.
Sir.
Over here, I've got natural log of 3 times 5x.
5x minus the natural log of 3.
On that. Okay. Now we're solving an algebra problem. In other words, it's no longer an exponential problem. How do you solve algebra problems where there's only one variable, x? What's our next?
We get x on one side.
Correct. We get all the x on one side. Put everything else on
That's right.
So I'm going to move everything to the right side, just because that leaves our coefficients positive for the moment. With me? And
yes, sir.
The other side is, let's go ahead and change that to the natural log of 25 plus the natural log of 3. What's the next step? And it usually is.
We can.
The sequence is always the same. What would you do if these were numbers on the right side?
Combine like terms.
Or how about let's factor out an x? Remember,
Okay, factor out an x.
we're trying to solve for x. So I want the final thing at the bottom to say x equals in some complicated expression way over there. And the way we're going to do that is by factoring out an x. So
that's right.
X times what?
X times 5 times log 3, natural log 3.
Hold on. Okay, hold on. Natural log. Excuse me, hold on a second. X times, okay, let me get clear here. 5 times natural log of 3 minus 2 times natural log of 5.
Minus 2. That's right.
Hold on. We factored out an x, so that left a 5 natural log of 3 behind and a 2 natural log of 5. Okay. So now our final solution is going to be that divided by that. And let's go ahead and move those back up to exponents. In other words,
all right,
the thing over here, sorry, is the same as natural log of 125. That's 3 to the 5th. Oops, no it isn't.
That is 27. Natural log of, wait, no.
3 to the 5th is 81 times 3. I think that's 241.
243.
243, thank you. Plus natural log of 25.
25. Minus or plus?
Minus. Now we can do more simplification. In other words, now the numerator here, write smaller. This numerator right there is the same as the natural log of 3 times 25.
Yes, sir.
The denominator
So the natural
is the same as natural log of 243 divided by 25, which doesn't divide evenly. Shoot.
Okay, so
There's nothing wrong with that answer, I don't think. It's your final answer for x.
I guess so.
Seems like it should be able to be simplified because we have a base 5 here. That's 5 to the 3rd, and this is 5 squared. And this is 3 to the 5th. Don't think we can do anything with that. It's kind of like trying to do something with x over x plus 1. You can't. Do you have answers on
Yes,
this?
sir. I think that's the right answer.
Okay. All right.
I think it is.
Do another one here. These all boil down, well, they don't entirely boil down, but they usually boil down to just those 3 rules of logs. All right, let's look at this one. So 16 to the y equals x for this part.
That's right.
Then the log base 4 of x equals what? Well, I can take the log base 4 of both sides of the top equation. Right? You can always do that.
Yes, sir.
In other words, I can always take the log base anything of both sides. And I meant to write that as x, right?
Yes, sir. Sorry, your microphone seemed to go silent for a second.
Yeah, x was equal to 16 to the y power. And then I took the log base 4 of both sides. So here's my right side. That's what they want to know what that's equal to. Well, it's equal to this. I'm going to move the y down in front. And then what is the log base 4 of 16 equal to?
Log base 4 of 62.
Yeah, so the log base 4 of x equals 2y.
Yes, sir.
Oh, here was the answer right there. So you did that one already. You got it right. At least you got the same thing I got.
Yes, sir.
All right. These problems all can be done by combining the left side into one log expression. They're all base 10, so all the logs have the same base. So what's the left side become if you combine it?
This is number 7?
Yeah.
Okay. So this is the log of 2x, or 2 minus x divided by x. No, wait. 2x plus, what am I saying? It's the log of...
Right? In other words, it's all I have to do is take the arguments and multiply them by one another. One argument
is 2 minus x.
The other argument is 1 over x.
So it is 2 minus x divided by x.
Yeah, although I hate to say it like that because that's a plus, what you're really doing is multiplying by 1 over x. But
that's right.
Tomatoes. Okay, so now we know that that is equal to the log of x squared. Okay?
Okay.
And now if the log of something, that something being this, is equal to the log of x squared, then that something has to equal x squared. So 2 over x minus 1 equals x squared. Going to multiply everything by x.
Yes, sir.
I get 2 minus x equals x cubed. Now what are they giving you a quartic for? X cubed plus x minus 2 equals 0. I don't know how they expect you to solve that. They haven't taught you to math to solve that. Because that's solving a cubic. Maybe they did teach you the math. You had the P over Q. In other words, if there is a rational solution for a cubic, its solution, its numerator is factors of that, its denominators are factors of 1. So if there is
P over Q?
Yeah, it's either minus 2 or plus 2 or minus or plus 1. Does either of those solutions work? Yes, +1 works. So x equal 1 is a solution. Notice 1 cubed plus 1 minus 2 does equal 0. So once you find one solution to a cubic, you can divide that cubic by that solution, by x minus 1, to come up with the remaining quadratic. Then you can apply the quadratic formula if needed. You might be able to factor it. Doesn't look like 2 works. And doesn't look like -1 works. The only solution that I see that's rational that works is +1. But like I said, you can divide that synthetically by 1, and whatever your solution is, that's your quadratic. And then you have to figure out whether you can factor that or use the quadratic formula on it. But you can come up with 3 solutions. Now, here's the kicker. You have to make sure, and this is the most important part, you have to make sure that none of those 3 solutions violates this domain, or this domain, or this domain. If any of them do, then that's not a solution. In other words, this may only have 1 or 2 solutions. 1 doesn't violate it. Notice that 2 minus 1 is still a positive number. 1 over 1 is still a positive number. And log of 1 is 0. You can take the log of 1. You just can't take the log of 0. You can't take the log of negative numbers. So, knowing that 2 is not a solution and -2 is not a solution means you're going to have a positive and a negative solution as your other 2 solutions. Throw out the -1. That's going to violate this domain. That's going to violate that domain.
Yes, sir.
So you're going to end up, I think, with 2 solutions for this. X equal 1, and whatever the positive solution of the remaining quadratic is that you get when you synthetically divide that by +1. You can probably get it really quickly here. That becomes 1, adding, that becomes 2, times that becomes 2, which is 0. So the quadratic is x squared plus 2x. So we have x times x times x plus 2 as our 3 apparent solutions. Those 2 you got to throw out because those can't be equal to 0.
Yes, sir.
So, x minus 2, I don't know. I might have made a mistake in my haste here. But I think you get the idea.
Yes, sir.
In other words, when you end up with this cubic, assuming that that's a correct cubic, that I didn't make a mistake already, you're going to come up with 3 solutions. One solution is clearly the number 1. The other 2 solutions, I don't know how I got those 2. The other 2 solutions, it's just 1. It's x times x plus 2. But that one you got to throw out also because x can't be negative. So both of these other solutions, you have to throw them out. And the only solution we have left is this one right here, x equal 1. Only solution to that.
Yes, sir.
Okay? Garrison, I'm going to let you go.
Yes, sir.
Is this an okay place to start next time, or do you have a pressing need to, you have a quiz on matrices or anything?
I think I'm gonna have a test on matrices on Friday.
Okay, let's just have, we won't do it now, but let's make sure I know which ones we want to work on.
Wait,
Okay, so you're
or
going
it's
to,
not. It's not.
this page right
Hold
here?
on. It's not. Yes, sir.
Okay.
Well, hold on. The quiz. It's not matrices. It was cis. That was
Systems
my
of
bad. That was
equations.
a mistake.
But you're going to use matrices to solve it. In other words, they want you to do it with these reduced row echelon format. That's what that means.
Yes, sir.
RREF means reduced row echelon format. So you're going to solve this system of 3 equations and 3 variables by using that technique that we talked about last time that I said I would get back to you on. But it looks like you've done a pretty good
Yes, sir.
job over here. That's kind of one way to do it. Notice I don't have to have zeros everywhere. I just have to have zeros below and to the left.
Yes, sir.
I suspect that that is a 1 right there also. In other words, yeah. So we'll work on this next time then, if you have a test on Friday on it. Now, do you know how to do those in your calculator?
Yes, sir. We have those
In other words, once
functions in
we
our
set them
calculator.
up and you can do them manually, you know how to put it into your calculator? Because I would have to go to YouTube
Yes, sir.
to figure that out. I can show you how to manually do these. Okay?
Yes, sir.
Okay, Garrison, I'll talk to you on Thursday.
Yes, sir.
And we'll begin
All
here.
right.
Okay, bye-bye.
All right. Have a good day.
You too.